All right. And you pause this until it works.
Okay, I heard you.
Chapter 2, we're dealing with fractions, multiplying, dividing fractions. The first part, the first section, the basics of fractions. What is a fraction?
Numerator over
So-
denominator. One number over. I'll just take. Mr. If I just take pictures of it, whatever you did.
That's, it'll be posted online. So all this stuff will be on there. So a fraction is simply a part of a whole or a part of a total. So if I said 3, if I said 3 of 5. They have 5 spaces. And I shade 3 of them. So this is the part over the total or the whole. Turn off the light then. But anyway, fractions represent parts of an entire picture. So it's part of a total. You do, no matter what the object is, the shape is. You still just shade 3 pieces out of 5. The numerator is the top number. Over the denominator. So it's the numerator at top, denominator at the bottom. The numerator larger. So if the numerator is larger than the denominator, it is called an improper fraction. Like 9/4. Proper fraction has the numerator less than the denominator. That's a proper fraction. Because if you have an improper fraction, then we have to convert it to a mixed number. Right, so that's the whole nother topic in itself, how to convert those. With these numbers here, we have 3/4, 5/9. Shh, guys, quiet.
I can't see them.
So which one of these are proper? Which ones are improper? Is the first one proper or improper? Proper or improper? Because the top number is bigger than the bottom, it's improper. The rest of these, the top number is smaller than the bottom, so they're proper. That's all it's asking for there. So that's that section. Now, section 2 deals with mixed numbers. The reason they're called mixed numbers is because it has an integer and a fraction. So 2 1/3 is a mixed number. Mixed numbers come from improper fractions. So the integer part tells us number of times the denominator fits into the numerator. The numerator is what's left over. So how many times does 3 go into 5? It goes into once. So what's left? If 3 goes into 5, what do we have left? The bottom number is always the same. If it's a bottom number here, it'd be bottom number here. I'll get there. It's an improper fraction. How many times does 5 go into 19? Yeah, 5, 10, 15. So it's 3 times. It's from 15 to 19 is so, and then if we did long division, let's see, if we did long division, 3 goes into 5 once. 1 times 3 is 3. So here you have your coefficient. Here you have your numerator. And the denominator is always the denominator. So 5 goes in 19. 5 goes in 19 3 times. 3 times 5 is 15. Subtract it. I get 4. So this is my coefficient. This is my numerator. And this remains my denominator. So far, so good? Anybody else? So we have any, going to do some more? Okay. The hardest part of this, again, it's the multiplication table. Send me a reminder. I will make you all some multiplication, small multiplication cards that you can use for quick reference. It'll make it much easier for you. So we can look at how many times is 9 going to 31? 3. 3 times 9 is 31 minus 27 is. So this is my coefficient. This number goes on top. This number stays on the bottom. Yeah. When you have a negative value, this negative simply goes out in front. Don't worry about it. It just says the entire thing is negative. We just do what we just normally did. 4 goes into 15 3 times. 4 times 3 is 12. Subtract that. 15 minus 12 is 3. So that goes there. The 4 stays on the bottom. And the 3 goes on top. So even if it's negative, it doesn't change anything. It's still going to be negative if you just do the same process. Let's go backwards. From mixed number to improper fraction. Here's the formula. So whatever the coefficient is times the denominator plus the numerator. So 2 times 3 plus 1 over 3. 2 times 3 is 6. 6 plus 1 is 7 over 3. And there's your answer. So it's 5 times 9 plus 4 over the denominator. 5 times 9 is 45 plus 4. 45 plus 4 is 49 over 9. That makes sense? Want to do a couple more? Well, we haven't done negatives yet. Or the negative just goes there. 2 times 4 plus 3 over 4. 2 times 4 is 8 plus 3 over 4. 8 plus 3 is 11 over 4. So just do the whole thing, just put a negative on top. Let me give you more there. You okay with that now? I mean, I'll do more if you want. And when we do more, that's what, let me try to find some. Oh. That's all there was. Let's try number 15. 10 3/4. We'll multiply those. Add that. All right, let's go backwards again. $29 over 13. $13 goes in 29 how many times? 2 times 13. Subtract them. 29 minus 26 is 3. Whatever is on top goes in front. This stays on the bottom. And this number goes there. Again, the hardest part is the multiplication. You have to know your multiplication tables, how many times something fits in something else. Question number 53. 183 divided by 7. So 7 goes into 18 how many times? 2 times 7 is 14. Put a 0 there. 18 minus 14 is 4. Bring down the last number. 7 goes into 43. 7 times 5 is 35. 35 plus 7 is 42. So it's in there 6 times. 6 times 7 is 42. Subtract them, you get 1. So 26. That goes in front. This one goes on top. This one stays on the bottom. All right, so that's that section. Chapter 2, section 3. Factors. When you factor something, you break it down to its smallest pieces. P-I-E-C-S. So for example, the number 10 is made up of 2 times 5, and they can't go any further. So you have prime numbers. What are prime numbers? Numbers that are only divisible by 1 and itself. Those are prime numbers. Example 1, 2, 3, 7. Because those can't break that any further. Those are all prime numbers. The other numbers composite or compound numbers made up of more numbers than one and itself. Six is also divisible by 2 times 3, 1 times 6. Prime factorization. Is breaking a number down to its prime numbers, where you can't go any further. All right, so prime factor, that's what we're going to do now. We're going to look at that. So number 32. We use the factor tree. So what's the smallest number that fits in that one? Since it ends in an even number, if it ends in an even number, then it is divisible by 2. So look at the last digit. If it's an even number or 0, even number or 0, then it's divisible by 2. So we know 2 goes in there. Two goes into 3 how many times? Once, with 1 left over. So 2 goes into 12 6 times. Again, it's the multiplication table that's going to get you. So 2 is a prime number, can't go any further. 16. It ends in a 6, which is an even number, so 2 goes in there again. How many times does 2 go into 16? 8 times. 2 is a prime number. 8 is a composite or compound number. 8 is made up of 2 times 4. 4 is made up of 2 times 2. So 32 is made up of 1, 2, 3, 4, 5. 2 times 2 times 2 times 2. 5 times. Make sense? Again, the hardest part is going to be the multiplication part. So what goes into how many times? 156. It ends in a 6, which is an even number. So I know 2 goes in there. 2 goes into 15 how many times? 7. 2 times 7 is 14. That means 1 left over. 2 goes into 16 8 times. Again, ends in an even number, so I know that 2 goes in there. 2 goes into 7 3 times. With 2 times 3 is 6, plus 1 is 7. So there's 1 left over. 2 goes into 18 9 times. Uh-oh. Ends in a 9. We know 2 doesn't go in there. But if we take the 2 digits, 3 plus 9, that equals 12. Is 12 divisible by 3? So if you add the numbers and they're divisible by 3, then that whole number is divisible by 3. So I can divide this number by 3. If the sum of the digits in a number is divisible by 3, then the number is divisible by 3. For example, 29,412. Is that number divisible by 3?
Yes.
Yeah, if you add up all the digits, what does it equal? 9 plus 2 is 11. 11 plus 4 is 15. Plus 1 is 16. Plus 2 is 18. So 18 is divisible by 3. So that means this whole number is divisible by 3. So that's to help you get unstuck. So 3 goes into 3 once. 3 goes into 9 3 times. And 13 is a prime number. So 156 is made up of 2 times 2 times 3 times 13. That's prime factorization. Why do you think we do prime factorization? Well, yeah, that's what prime is. So that's what the whole process is, breaking it down. But the reason we do that is to simplify fractions. We'll come back to this one. Let's come back to this one. I don't do that just yet. We'll come back to this one. Let's do this one first. Six divided by 15. Let's do something easy first. 6 is made up of what? 2 times 3. What's 15 made up of? 3 times 5. In division, as long as you have the same number in top and bottom, you can get rid of them. You can cancel them. Since the 3's are gone, what are you left with? 2 and 5. And there's a simplified version of it. What? Let's try another one. 24 over 56. So 24 is made up of 2 times 12. 12 is made up of 2 times 6. 6 is made up of 2 times 3. So it's 2, 2, 2 times 3. $56 is made up of, and 2 goes into 5 twice with 1 left over. 2 goes into 16 8 times. 2 goes into 2 once. 2 goes into 8 4. 14 is 2 times 7. 2, 2, 2 times 7. So once we prime factorize it, we simplify as far as they can go. We just cancel anything the same on top and bottom. So our final answer is 3 over 7. That's the reason we learn how to prime factorize numbers, to simplify fractions. Pretty good. Let's try this number up here. Simplify this number. So I have 128 and 264. So 128 is made up of 2 goes into 12 6 times. 2 goes into 8 4. Ends in 4, so it's 2. 2 goes into 6 3 times. 2 goes into 4 twice. Ends in an even number. 2 goes into 3 once with 1 left over. 2 goes into 12 6 times. 2 times 8. 2 times 4. 2 times 2. So it's 1, 2, 3, 4, 5, 6, 7. There's 7 2s. 2 times 2 times 2 times 2. That's 128. Now get to 264. 2 goes into 2 once. 2 goes into 6 3 times. 2 goes into 4 twice. There's 1 2. 2 goes into 13 6 times with 1 left over. 2 goes into 12 6 times. What's 66 made up of? 2, since it ends, 2 goes into 6 3 times, 2 goes into 6. 33 is 3 times 11. So we have 1, 2, 3, 3 and 11. Now we reduce. Those 2 cancels, those 2 cancel. Two times 2 times 2. Two times 2 is 4, times 2 is 8, times 2 is 16. 3 times 11. There's a simplified version of that fraction. Am I going too fast? So once you learn the pieces, you start putting them all together and see what it does. Is all we have is a number and just start breaking down the pieces. Even if it was a mixed number, or an improper fraction. There we finish. Are we done? That's an improper fraction. But before you do anything with it, simplify it. Prime factorizing. So 105 is made up of, well, since it ends in a 5, if a number ends in a 5 or 0, then it is divisible by 5. So if it ends in a 5, it's divisible by 5. So 105 ends in a 5, so I know that 5 goes in there. 5 goes into 10 twice. 5 goes into 5 once. $21. 2 plus 1 is 3. So this number is divisible by 3. 3 times 7. Ends in a 5, so I know 5 goes in there. 5 goes into 45 9 times. 9 is made up of 3 times 3. So the numbers are 3 times 3 times 5. Once I prime factorize it, now I can cancel. These threes cancel, these fives cancel. This number is a lot easier to make into a mixed number than this. How many times is 45 going to 105? That's twice, but with what left, a whole big number left over. How many times is 3 going to 7? 2 times with 1 left over. And there's your answer. So the whole purpose of factorization is to make the numbers smaller so you could easily handle them. Any questions so far? Writing fractions in lowest terms. What section was that? Writing fractions in lowest terms. That's what we've just been doing. That's called, in a nutshell, that's called simplification. Take the top number and the bottom number, simplify as far as it goes, and that's you're at the lowest terms possible. You're not done in a math equation. You're not done until it's simplified as far as it can go. $15 is made up of 3 times 5. 25 is 5 times 5. I can cancel the 5s. What I'm left with is 3 over 5. I can't go any further. This number can't be broken down. So there's my answer. So once you factorize everything and cancel whatever you can, whatever you're left with is your final answer. That's all this section does, is write your answer in the most simplest form. There's not much I can say about that one. Simplify that one. Again, what do you start off with? Factorize it. 21 to just what number goes in there? 3. So 3 goes into 21 7 times. So it's 3 times 7. 36 ends in the 6. So I know 2 goes in there. 2 goes into 3 once with 1 left over. 2 goes into 16 8 times. 2 goes into 18 9 times. So it's made up of 2 times 2 times 3 times 3. These threes cancel. Oop. So the final answer is 2 times 2 is 4 times 3 is 12. That's as far as you can go in that equation. What do y'all think? Are fractions still horrible? We haven't gotten to adding, subtracting, multiplying, dividing yet. Those are getting easier too. That's all it's telling you to do. It takes about many pages to tell us that. If you prime factorize it. Multiplying fractions. I'll wait. I'll pick at the end. Section 5. Multiplying fractions. Here's the rule. When you're multiplying fractions, always reduce first. So if I had 2 over 5 times 10 over 25. Can anything on top cancel with anything on the bottom? Well, this is where right now, until your multiplication skills get better, prime factorize it. So we know 2 and 5 can't go any further. 10 is made up of 2 times 5. 25 is made up of 5 times 5. So when you're multiplying fractions, everything on top multiplies and everything at the bottom. Once everything cancels, 2 times 2 is 4, 5 times 5 is 25, and there's your answer. Cancel everything on top and bottom, anything that fits in each other first, cancel that first. And then whatever you're left with, multiply them out. That breaks down to that. That breaks down to that. These fives cancel. Because the rule is this, whenever you're multiplying fractions, it's all in the same. You could combine the top numbers together and the bottom numbers and then take it from there. So anything on top can cancel with anything on the bottom. There's one. 5 over 8. 3 over 4. 1 over 2. What do you mean? Ideally, what you want to do first is prime factorize everything. 5 times 3 times 1. 8, 2 times 4, 2 times 2. So the bottom number has a whole bunch of 2s. The top doesn't. So it's 1, 2, 3, 4, 5, 6 2s. Nothing cancels. So multiply top by top. 5 times 3 is 15, times 1 is 15. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, 64. That's as far as you go. It cannot simplify any further. If you can't cancel here, then you can't simplify any further there. It's already done. It's all the simplification is done. How about those? Where would you start doing first? Prime factorizing. So what's 42 made up of? 2, 21. 21 is 3 times 7. So it's 2, 3, and 7. 18 is made up of 2 times 9, 3 times 3. So it's 2 times 3 times 3. Those are the two top numbers. $56. 2 goes in there. 2 goes into 5 twice with 1 left over. 2 goes into 16 8 times. 2, 14, 2, 7. 2 times 2 times 2 times 7. So that's 56. 21 is 3 times 7. So once you prime factorize it, what do you do next?
Cancel.
Cancel. Anything is same on top and bottom, cancel. So this 2 can cancel. This 3 and this 3 can cancel. This 7, this 7, this 2 and that 2. So on top, I have 3 times 3 and 2 times 7, which is 9 over 14. That's as far as I can go. Never multiply first. Always reduce first. Because if the numbers are big and you're multiplying together, it'll be even bigger when you multiply them. Then that's a lot more work you have to do to factor it. When they're small, you can factorize it much easier. So take the numbers, factorize them, cancel, whatever you're left with at the end is your final answer. And it doesn't matter how many terms you have. You still finished? Okay, you're still lost? Where? Well, yeah, if you keep on doing other stuff other than this, of course you'll get lost. Yep. Let's see here. Let's put a whole bunch of numbers together here. 14 over 21. 7 over 9. 36 over 42. And 8 over 12. What's 14 made up of? 2 times 7. So it's 2 times 7. What's 21 made up of? 3 times 7. 7 is a prime number. 9 is made up of 36 is made up of 2 goes into 3 once with 1 left over. 2 goes into 16 8 times. 2 times 9, 3 times 3. So it's 2 times 2 times 3 times 3. (42) is made up of 2 times 3 times 7. Eight is made up of 2 times 2 times 2. (12) is 2 times 6, 2 times 3. So 2 times 2 times 3. That's the hardest part. Breaking down the numbers in the prime factors is the hardest part. Once you get that far, anything on top cancels with anything on the bottom. This 7 and this 7 cancels. This 2 and that 2. This 7 and that 7. That 2, that 2. This 3, this 3. This 3, this 3. That 2, that 2. Let's see what we have left. on top. 2 times 2 times 2. 3 times 3 times 3. Do they cancel anymore? 2 times 2 is 4 times 2 is 8. 3 times 3 is 9 times 3 is 27. That's the answer to this big question here. Basically, I'm saying is it doesn't matter how big the equation is, as long as you break it down to its smallest pieces, it's manageable. What do y'all think? I mean, I can't answer questions unless I have questions. Just staring at the board, it doesn't help me much. Do you understand what I'm doing so far, or are you still lost? Anybody have any questions? Okay, I'll keep on moving. Multiplying whole numbers times fractions. The first thing you have to do is make this number into a fraction. Every integer is divided by 1. Has a 1 beneath it. So can anything on top cancel with anything on the bottom? No. Since nothing does that, then we have to multiply straight across. 2 times 3 is 6. 1 times 5 is 5. Are we done? No, it's a improper fraction. So how many times does 5 go into 6? With how many left over? The denominator. There's your answer. So it doesn't matter what you multiply it by, it's still gonna give you the same answer. Well, let's see what else there is. Yeah, let's go ahead and stop there. We've done 5 sections in chapter 2. By now, you should be finished with chapter 1. You should have finished the homework, taken the test. Because now we're in chapter 2. We'll be finished with it. We'll be finished with chapter 2 next class. Oh, you need this one also. You need this one also. All right. So if there aren't any questions.